Here we're trying to simplify this expression given to us. And before I begin, first let me just say that the answer is actually incorrect. This should actually say negative x to the a power. Okay, with that being said, let's begin. So first off, what I need to do is I need to factor. And it looks kind of weird because I have the variables in there in the exponents. But what I want to do is I want to factor out what I can. So if I take a look at the numerator of this first term over here, x to the 2a minus 3 minus x to the 2a minus 5, notice they both have an x to the 2a in common. So I can actually pull out an x to the 2a. So when I do that, I'm left with x to the negative third minus x to the negative fifth here in parentheses. If I'm not sure if you did it correct, you can always distribute back through and see, okay, do I have what I initially started with? So when I distribute, I notice that I do, and it works. So I do the same thing again for the denominator, where notice I can pull out an x to the a. Okay, they have an x to the a in common, so when I pull that out, I'm left with x to the negative 6 minus x to the negative fourth. And then on the right side over here, this is actually a divide sign. It's not plus, it's not multiply, this is divide. So I divide by this fraction over here. I'm actually multiplying by the reciprocal. So that's what we did in this step over here, is we wrote the reciprocal but then also factored out things in the process. So if you look at x to the a plus 2, we can think of it as two parts. We can think of it as x to the a times x squared, because when I multiply with the same base, I need to add the exponents. So if I multiply these together, I would actually get x to the a plus 2 power. Okay, so that's going to be that. And then same thing for the numerator, which would become the denominator when you divide. It's going to be x to the a times x to the third power. So what I do from here is I just simplify. X to the a's can divide out. I'm left with x squared over x to the third, which would become 1 over x. Okay, so that's how we get this right here. And now this other half is kind of messy. And a technique I'm going to use with these negative exponents, I'm still going to pull out what I can. I'm going to factor out what I can. But to do that, I'm actually going to pull out the most negative exponent. So for example, looking here in this part, the most negative exponent is negative 5. That's the smallest exponent. So I can pull out an x to the negative 5. So I pull that out, I'm left with, in parentheses, x squared minus 1. Okay, if you're not sure, you can always kind of think backwards, and you can distribute, and you can check your answer and see if you would get what you started with. So when I multiply x to the negative fifth times x squared, I would indeed get x to the negative third. Same thing for the last term, and I would get x to the negative fifth. So that's fine, that works. And then, also, we can cancel these x to the 2a over x to the a. That would cancel. I'm left with an x to the a power right here. Okay, and then for the denominator, same thing that we just did for the numerator. I can pull out the most negative exponent, which would be, in this case, negative 6. So I pull out x to the negative 6 power. So when I do that, in parentheses, I'm actually left with a 1 minus x squared. Okay, that's where the mistake was. This should say 1 minus x squared. And then I want to start canceling things out. So notice how it's 1 minus x squared is basically the same as x squared minus 1. To make it the same, I can pull out a negative, and that would make this x squared minus 1. So I pull out a negative, and that's going to create this right here. So now I can start canceling a bunch of things. X squared minus 1s will cancel, and then x to the negative fifth over x to the negative 6 will cancel, and I'm left with an x on the top, which the x on the top would then cancel with the x down here. So what I'm left with is just x to the a, but then don't forget we pulled out that negative. So it's going to be negative x to the a power. So your final answer should be negative x to the a.